Telling the difference between discrete and continuous. Again, write yourself briefly what it is. For the first one, I would just say number of books, discrete. When you see the word discrete, that means nothing. Number of books? Oh yeah, I can count those. Those are countable. 1, 2, 3, I can count them. X represents length of time. Can you have a half hour? Can you have a half a minute? Can you have a half a second? Yeah. If you can ask yourself, can you have a half? You're continuous. The volume of blood, continuous. The number of tornadoes, discrete. The number of messages, discrete. How many just put the answer down there? Yeah, those are no good when you look at your homework later. X represents the amount of snow in inches. Can I have a half of an inch? Yeah. 0.2 inches? Yeah. Continuous. Okay. Here's a probability graph. I left some of these blank because I figured we can fill them in rather than you looking at them writing the answers. I'm trying a different approach. Maybe we need to fill more of these in. Okay, we're going to construct a probability distribution, and I find this one very, very important. So I should see this table on your papers. Now, these are the number of televisions per household in a small town. You have to construct a probability distribution. The distribution is your table. You have to graph this like a histogram. That's your relative frequency histogram. And some of the questions were also related to your chart. Once you put your probabilities on that chart, you're going to go right to your questions for it. So, how do I do this? How do I find the probability of these things? I've given the x and the frequency. How do I find the probability? Add the frequency. And what does that add to?
2600.
Okay, now what do I do with that? So divide 0 divided by 2600, 1?
No.
26. 26 divided by 2600. So what does that become?
24.
Okay, 442 divided by 2600.
433.
The next one. Wait, what?
28.
And the last one. What should these all add up to? 1. All your probabilities should add up to 1. To be a probability distribution, what are the two things that have to happen? Good. Each probability has to be between 0 and 1. Good. And the sum of the probabilities has to be 1. Good. So, yes.
This one is under, then it can't work, right?
If it's under, well, did you make the
Oh no, I'm not talking about for that. I'm talking about like for
Oh yeah, if they give you a table, if it's under, yeah, it has to add up to 1. But sometimes what happens when you, like this was an even number, so they came out just, they terminated. But sometimes when you have, a rationals and you have to round, if you find you're rounding up too many times and not down, like it didn't even out, you may be like 1.001. And in that case, that's fine. That's fine. Now, our graph from this. Here's your x-axis. This is your x values. Even though it's a 0, start them here. Here's your x-axis. What do I put on my y-axis? P of x. Good. Your probability. You're making a probability distribution graph. A probability graph. So the probability goes on the y-axis, not the frequency. Now, the probabilities are like money. Goes from 0 to 55 cents. If you go, say, 0.20, depends on how much space you have. Make it equal. Go by 0.05s if you can. Go by 0.10 if you can. Give it a title. This was your number of televisions per household. Give it a title. Label your axes. These are your x values, your televisions. Okay, and make your bar graphs. This will give you 0.01. That's a really, really small one. 0.17. Make your bars touch. 0.28. 0.54. Okay. Now, where is this skewed? To the left. It's skewed to the left, which means, what can you tell me by looking at this graph in terms of the number of TVs that households have?
There's more
Right.
houses with three. There's more households with 3 TVs than there is.
Yeah, there's more households with 3 TVs. It looks like more households have more than 1 TV. Doesn't it look like that according to this graph? That's why the 0 is very small. That means nobody has a TV in those households. There were very few households that have no TVs. Then most households are having 3 TVs, according to this chart. It makes sense out of it. Now, when you come here to 21, it used the probabilities that you found in 19. Come right off your table. What is the probability that you have 1 or 2? First of all, are the entries in this table mutually exclusive? Yes. If you have 3, you obviously do have 2, but you would count it as a 3, not a 2. So it's to the highest number that you have. So we can add these. So go to your table. Probability of 1 is 0.17, plus the probability of 2 is 0.28. Add them together. That's your total probability. If you don't have this on your paper, you should be putting this down. That's for A. The probability of 2 or more. Well, according to our table, what is the more part of it? 3. 2 or 3. And we're going to add 2 or 3. 0.82. Pretty high. Most of the people are having 2, 3 TVs. Between 1 and 3. Did it say inclusive? I didn't write that down. It did say inclusive. Inclusive. What does the word inclusive mean? Including. You include. So, I want between 1 and 3 inclusive. I add those pieces up. Before I add these up, I don't have a calculator handy. What's an easier way for me to do this? Leslie's smiling. What is it? Subtract the 0 one. 0.01. Isn't that much easier? What case is that called? No, the complement. With an E. Complement case. Take your probabilities right off your table. Yes? Questions? No? You're good. Okay. All right. These guys, you just had to say if they work. And Daniel told us the 2 things we're looking for. The probabilities have to be between 0 and 1. And the sum of all probabilities have to equal 1. And this one had a mistake. We found it yesterday. This one had a mistake. It says 0.5. It should be 0.05. 0.5 would put you more already. And we looked up the answer in the book, and the answer was based on 0.05. And how would I find that? I would add up all of these and subtract it from 1 to see what the missing part was. Number 27, it is a probability distribution. Probabilities are between 0 and 1, and the sum is equal to 1. You can use fractions as well as decimals. So in your fractions, you can just, it doesn't matter if you leave them in fraction at the end, leave them in decimal, find a common denominator, put them in your calculator, whatever it is you want to do. Add them all up, the sum was not equal to 1. To convert to a common denominator, convert them all to hundreds. They're all in a convertible state there. 29, I gave you 29. Now, 29. Did everybody get this? Okay, so let's walk through 29. We have, let me get a clear space. to work right in his face. Okay, 29 says the number of dogs per household in a small town. Mean, variance, and standard deviation you had to find. So let's just write these down. I want to do it together with you. Dogs, this is your X value. Frequency, this is your P of X value. Now, you don't have to do this part, but should you do this part, X times the P of X, that sum is going to get you the mean. But I told you didn't have to because you can put this in your calculator. But since we looked at this yesterday, we'll do it today. Oh, they didn't give you the frequency. They gave you the P of X. Okay, now, they want the mean, the variance, and the standard deviation. Same exact thing as we do before. L1, L2. Now, we know when you have a frequency, we did the frequency to get the probability. Well, whatever the frequency was, they added them all up, divided part over whole, and got the probability. So it's the same exact thing. Now, when you put this in your calculator, you need to think for a second. If you hit this, it's only using L1, but you have an L2. You have to say L1, comma L2. On the 83 calculators, the black calculators, the ones we went out here, you have to say L1, comma L2. Okay. Let me give you a pass. So, everybody, multiply those across for me. And your test. Multiply these across. Well, no. Sorry. Put them in your L1, L2. Put them in your L1, L2. And make sure you do this. On yellow, when you do the yellow calculators, it's going to ask you for your X values. That's your L1. And where it says frequency, that's your L2. Remember yesterday we determined, because this is equal to 1, all your probabilities have to equal to 1, that you will not get a sample standard deviation when you use this part of it. And that's fine. So what you mean? 0.528. Okay, what's your OX, your population standard deviation? It's 5 what? 02. Did we say 502, Rebecca?
No, for the mean it's 2.5.
Yeah, it's got to be closer in a whole number. It's got to be around 2 or 3. How could it be point? Oh, okay, because it's higher up here. 0.502. Okay. Okay, let's see what you did wrong.
Oh no, I forgot to put in the L2 for the frequency.
And your standard deviation, what would that be?
The 0.9.
0.912. Okay, now, this is my standard deviation. How do I find my variance?
You square it.
Theirs, you square it. So go to theirs, go down to statistics, pull out your standard deviation, and square it. That gives you your true variance. The calculator does it before you take the square root. It does the whole thing out. You're only rounding this should you square this one.
You go to theirs.
Theirs, go to the word theirs, go down to number 5,
And then hit 4.
and square it. So what do you get for your variance? Okay, 0.832. You didn't find it? go, hit the there, go down to the 5, and look for OX, the standard deviation, hit that, and then hit the square button. What can't?
I was in
Oh, that'd be
It's
like,
probably from the last class.
yeah, maybe, no, probably you guys were doing this yesterday in class.
Oh, yeah.
Yeah. Okay, now, is everybody okay with this? Oh, that was today's, but that's okay. This is today's lesson, so that's, oh,
No,
no, I just moved it down here. So thank you. I'm getting confused. All right, now, we said yesterday, if we multiply this column times this column, and then we add these down, this was also equal to your mean. Now, your mean tells me, what does this mean tell me? These are the number of dogs and the frequency of households. So, what does that mean of 0.502 tell me, according to my chart? Well, it's going to be skewed. It's going to be skewed to the higher numbers to the right, because it's less over there. But what does that average mean?
It's like half dogs.
Not half have dogs.
More than half have dogs.
The average number of dogs per household is 0.5. It's kind of like the average number of children is 2.5 per household. Does that mean you have a half of a child? No. But look what happens. Right here, that's the biggest portion, isn't it? The biggest portion is 0. So most people have no dogs. No dogs, according to the ones that they surveyed. But on the average, 0.5 dogs per household. The way it averages out. Same thing when you read the average amount of children, 2.5, and nobody has 2.5 children. So remember, that's where your averages come from. So you should be able to do a chart like this. Okay, did you have to do anything else with this? Just interpret your results. Okay. Yes. All right, and I think you had to do 33. Okay, let's do this together. The histogram shows, they gave you a histogram. It shows your hurricanes. Your hurricanes, and again, this didn't have a 0 because if you have a 0, you don't have a hurricane. These are your rankings for your hurricanes. So I took them off your bars here. Your bars went like this. Which way is this skewed? To the right, follows the tail. Skewed to the right, it follows the tail. Now, all they wanted to know from this is your mean, and your variance, and your standard deviation. But they gave you all the numbers. So if it's easier, put your numbers in a chart. And again, you're going to do L1, L2. To get your mean, your standard deviation, and your variance, go to stat, pull out your standard deviation, and square it. So you should get a mean of 2.0. You should get a standard deviation of about 3.4. You go to square that, and your variance should be about 1.8. Oops, nope, your variance. Hang on, I got this wrong. Your variance, your standard deviation should be about 1.0, and so should your variance. Your standard deviation and your variance are about the same because of the rounding. They're about the same. Square root of 1 is 1. So, L1, L2. You have to say the L2. Now, at this point, you should realize that you have to do that. Think before you hit the key. Think what you're getting. Your calculator's a great tool, guys. However, what happens in the calculator